In this problem, we want to determine whether each function is even, odd, or neither. So let's go look at the graph. I'm going to press my y equals, clear. I'll put my beginning parentheses, x plus 2, closing parentheses, and then caret 3. And then graph. Now as I look at this, it's obviously not even. I get my pen to work. There it goes. Because if I were to take this piece right here and flip it, reflect it across the y-axis, there's nothing for it to land on here. And it's definitely not odd, because if I start with the same piece, if I flip it across and then flip it up, there's nothing for it to land on here. Remember, even, you try to flip it once, and odd, you flip it twice and see if it lands on that part of the graph. So this is a neither. Now let's look at this algebraically. Now I'm happy with doing it with the graph, so I'm just showing this for fun. Look at even, and then we'll look at the odd. Well, for even, to see if something's even, what you do is you plug negative x in for x, and see if you can get it to equal the original function. So we've got negative x plus 2 to the third power. Now I could factor out a negative 1 here. So factor out a negative 1, and that would give us x minus 2 to the third power. And if since these are multiplied together and I got it to a power, I can take the negative 1 to the third power, and I can take the x minus 2 to the third power. Well, negative 1 to the third power is negative 1, or just negative. And then this is just x minus 2 to the third. And it's close. I mean, I got the x by itself inside the parentheses here, but then this is a minus, and we got a negative out in front. So there's no way I can get it to equal the original. Now for odd, what we do is we put a negative y in for y, and we put a negative x in for x. And I'm not going to show all those steps here, but it's the same steps here, so we can get the negative out in front, like that. And now we can multiply both sides by negative 1. And we get y is equal to x minus 2 to the third power. Well, it's close to being equal to original. The y is by itself, the x is there, but the sign's wrong inside. So the answer to that is no. If the answer is no to both of those, then by default, it's neither. Again, I'm happy with the graph, so you don't have to do it algebraically.